Hi everyone, today we're learning about areas of circles, circumferences of circles, and volumes of cylinders. So first let's learn how to calculate the area of a circle. To calculate the area of a circle, we multiply pi, which is roughly equal to 3.14, by the radius squared, which is the radius multiplied by itself. Or we multiply 0.785 by the diameter squared. It does not matter in which order you multiply the numbers because multiplication is both commutative, which means that when you're multiplying two numbers together, it doesn't matter what order you multiply them in. For example, 3 times 4 is the same thing as 4 times 3, both equal 12. And it also doesn't matter when you have three numbers what order you multiply them in. So for example, 2 times 3 times 4, you can do 2 times 3 times 4, which is 12. So 2 times 12 is 24. Or you can do 2 times 3, which is 6, times 4, and 6 times 4 is 24. The area of a circle, the formula is area equals pi r squared. So now that we know this, let's do a few questions. So in order to rebuild a manhole, it will be necessary to remove the asphalt from an 11.5 meter diameter circle in a street. The pavement area involved is, formula is the area of the circle is equal to 0.785 times the diameter squared. So we know the diameter, so we're going to plug that in where it says diameter. So instead of the word diameter here, we have 11.5. And then we use our calculator. And we have 11.5 times 11.5 times 0.785. And we get 103.816 and so on. So the closest square meters to that for the answer will be 104, which is answer A. Next, if water is flowing in a 115 millimeter diameter pipe and it's discharged into a 200 millimeter diameter pipe, the velocity will do what? So the formula is that the flow rate in meters cubed per second is equal to the area in meters squared times the velocity in meters per second. Or velocity in meters per second is equal to area in meters squared divided by the flow rate in meters cubed per second. So the formula is area of a circle is 0.785 times the diameter squared. So what will happen with the velocity? So it's going from a 115 millimeter diameter pipe to 200 millimeter diameter pipe. So what we want to do is we want to figure out the flow rate. And so that will be the area times the velocity. So we figured out the area of the two circles using this formula here, area of circle. Well, it's also here, but okay, so the diameter for the first one is 115. So we substitute that in for the word diameter. And then for the second one, the diameter is 200. So we substitute that in. And we figure out what this ends up being. But notice that these are both in millimeters. So even though it says the area in meters squared, we're not too worried about that because we're comparing common measurements. If we wanted to, we could change these into meters easily enough because there are 1,000 millimeters in a meter. So this would be 0.1 and, 0.115. The 115 is already there. And this would be 0.200. So what we do is we multiply 0.115 times itself, or you can use the square button, whichever, times 0.785, and we get 0.01038. And then that would be meters squared. Don't have my tools right now to superscript that, so I'll just do that. And then the other one is 0.2 squared. So 0.2 times itself times 0.785. So we get 0.0314. So it's going from an area that is smaller to an area that's larger. So that means that the velocity is going to slow down because there's more space for the same amount of water. So we know it's either going to decrease to approximately half or it's going to decrease to approximately 1/3. Now we compare the numbers 0.0314 to 0.01038, and we can divide this by 0.01038 to see that it's about 3 times as large, so it's going to decrease to approximately 1/3 because it's now going through an area that's about 3 times as big, so the velocity will decrease to about 1/3. What is the surface loading on a clarifier with a 20-meter diameter with a flow of 8.2 megaliters per day? So megaliters is million liters. So the formula is that the surface loading rate in meters cubed per day over meters squared is equal to the flow in meters cubed per day over the area in meters squared. So the formula for the area of a circle again is 0.785 times diameter squared. So we know that it has a 20-meter diameter and the flow is 8.2 megaliters per day. So to find the surface loading rate, we need to know the flow, and we already know the flow, but we need to translate that into meters cubed per day, and we need to find the area. So to translate the 8.2 megaliters per day, we are going to remember that there are 1,000 liters in every meter cubed. So if there's 8.2 million liters, then we can figure out what the meters cubed per day is. And so to do that, we are going to divide that by 1,000 because there are 1,000 thousands and a million. So 8.2, well, 200,000, so 8,200,000 divided by 1,000 gives us 8,200. So that will be 8,200 for the flow in meters cubed per day. Now we need the area, so I'm going to copy this and put the 8,200 in. And I'm also going to find the area. So I'm going to use this formula and use the 20 meters as the diameter because that's what the diameter is. So I know that 20 times 20 is 400, but I can still calculate it here. 20 times 0.785 gives me 314. So the area of the circle will be 314 meters squared. And again, I don't have that superscript tool, so I'll just do that. So 8,200 divided by 314. So now we do that calculation to get the surface loading rate. And we get 26.114, so the closest one to it is answer A, 26.1. So next, let's learn how to calculate the circumference of a circle. So to calculate the circumference of a circle, we multiply pi by the length of the diameter. So circumference is equal to pi d, because it's pi times diameter. And again, pi is around 3.14. So now that we know this, let's do another question. What is the weir overflow rate of a sedimentation basin that is 25 meters in diameter with a flow rate of 5,500 cubic meters per day? So the formula for the weir overflow rate in meters cubed per day over meters is equal to the flow in meters cubed per day over the weir length in meters. The formula for the circumference of a circle is pi times the diameter. So what we're going to do is we need to end up with this, the flow over the weir length, but we also need to know the weir length, so we need to find the circumference of the circle. So to find the circumference of the circle, we do pi times diameter, and the diameter is 25 meters. So let's just actually copy this part. And, excuse me, we have for the diameter 25 meters, 25 times pi. So you can either use the pi button or you can use 3.14 because the multiple choice answers tend to be fairly far apart. It's probably not going to be an issue whether you decide to use 3.14 or the pi button. So I'm going to key in 25 times pi, and I get 78.5398. So I'm going to write that to 4 digits, so 4 decimal places, so 78.5398. And so that is the weir length. And now we need the flow, and the flow was given to us in cubic meters per day, which is what we need it in, so that's perfect. So that's 5,500. So now what we're going to do is we're just going to do that calculation. So 5,500 divided by 78.5398 gives us 70.02. So the closest is going to be B, 70 meters cubed per day per meter. So let's learn how to calculate the volume of a cylinder. So first, what is a cylinder? Well, basically it looks like a can. So there's a circular bottom, and then it has parallel sides that go up or down, however we want to think about it, the distance of the height of the cylinder. So a cylinder is a three-dimensional object with straight parallel sides and a circular cross section. So to calculate the volume of a cylinder, we multiply 0.75 by the diameter squared by the height. The reason that we do this is whenever you have a solid shape like this, the volume is the area of the base times the height. And if we look back to the formula for the area of a circle, we can remember that it was 0.785 times the diameter squared is the area of a circle. So now that we know this, let's do the rest of the questions. 12 centimeter pipe is running at full capacity at a flow rate of 3 meters per second. What is the flow in liters per minute? So we have that the formula of the area of a circle is 0.785 times diameter squared, and that the formula is flow rate in meters cubed per second is equal to the area in meters squared times the velocity in meters per second. So what we're going to do now is we are going to use the area of circle formula, but we notice that everything else here is in meters. So we don't want to have the diameter in meters, we want to have it in, or we don't want to have it in centimeters, we want to have it in meters. So we're going to have 0.12 there. So what we're going to do is we're going to multiply 0.12 times 0.12 times 0.785, and we get 0.011304. Okay, so that's the area of the circle in meters squared. And that caret means exponent. It means that the next number should be superscript. Okay, so now what we're going to do is we're going to use the flow rate, because that's really what we're asking for, is we're looking for the flow rate in liters per minute, but we'll adjust that at the end. So the area in meters squared is 0.011304. The velocity in meters per second is 3. So we're going to multiply this out now. So we have 0.011304 times 3, so that gives us 0.033912. And this will be in meters cubed per second. But what we wanted in is we wanted in liters per minute. So to translate this into meters cubed per minute, we're going to multiply this by 60 because there are 60 seconds in every minute. So 60 seconds per minute. So we're going to multiply that together, and that will give us the meters cubed per minute. So we have 0.033912 times 60, which gives us 2.03472. So I'm just going to put 2.0347. And that will be meters cubed per minute. But we want it in liters per minute. So remember that every meter cubed is equal to 1,000 liters. So we're going to need to multiply this by 1,000, or in other words, move the decimal point 3 places to the right. So we get 2.2034.7 liters per minute. So that matches this one here, B. Okay, so next we're going to do this question here. Calculate the capacity of a circular tank that is 14.6 meters, 48 feet in diameter, and 2,560 millimeters, 101 inches deep. So the formula is that the volume of a cylinder is 0.785 times the diameter squared times the height. So I'm going to copy this formula and plug in what we know. So we know that the diameter is 14.6 meters. And we know that we want the height in meters as well, so we're going to divide the number of millimeters by 1,000 to get the number of meters, or in other words, move the decimal point 3 places to the left. So now what we're going to do is we're going to calculate that. So we have 2.56 times 14.6 times 14.6 times 0.785, and we get 428.366336 meters cubed, and we know that every meter cubed is equal to 1,000 liters, so we're going to multiply that out, and we get the answer C. 428,366 liters is what it rounds to. What is the volume of water in a tank that is 15 meters in diameter and 4 meters deep with an overflow at 3.75 meters? So the formula for the volume of a cylinder is 0.785 times the diameter squared times the height. Now we know that it's not going to really stay past the overflow, so for the height we're going to use 3.75. And the diameter is going to be 15 meters, and we're going to multiply that out. So 0.785 times 15 times 15 times 3.75 gives us 662 meters cubed, which is, multiply that by 1,000 to get the number of liters. So that is 662,343.75 liters, or in terms of megaliters or millions of liters, that would be 0.66 megaliters, because it's about 2/3 of a million. So calculate the flow rate for a fire hydrant in your town where the velocity of the water supply in the hydrant was determined to be 6.2 meters per second, which is equal to 20.3 feet per second. And the pumper connection is 136 millimeters, which is 5.35 inches in diameter. So we have the formula for the flow rate in meters cubed per second, which is area in meters squared times velocity in meters per second, or Q equals AV, where Q is the flow rate, A is the area, and B is the velocity. And the formula for the volume of a cylinder, which is 0.785 times the diameter squared times the height. So we want to know the flow rate. So ultimately, we want to be able to plug information into this formula. So we're going to need the area and we're going to need the velocity. So we have the velocity. It's 6.2 meters per second. So we can start plugging things into our ultimate formula, basically. So 6.2 meters per second, and that is equal to that many feet per second, but we're going to work with the meters. And the pumper connection is 136 millimeters in diameter. So we need the area. So for that, we need the formula for the area of a circle, which is this again. So area of a circle, I'm going to just put the flow rate at the end since that will be our last calculation. So we want the area of the circle, and we want to plug in the diameter. So we want the diameter to be in meters. Right now it's given to us in millimeters. So we're going to divide by 1,000, remove the decimal point 3 places to the left, so 0.136. And we're going to multiply that out. So 0.136 times 0.136 times 0.785 gives us 0.01451, so 0.0145. And this would be meters squared. And now we can find the flow rate because we have the area. So we have the area being 0.0145, and we have that the flow rate is 6.2, well actually the velocity is 6.2 meters per second. So we have 0.0145 times 6.2, which gives us 0.0899 cubic meters per second. And then we know that it's not one of these answers because it doesn't match with one of these cubic meters per second. So we are going to convert this to liters per minute and see if it's answer C or answer D. So this is meters cubed per second. So we want to multiply that by 60 to get the meters cubed per minute, and then multiply that by 1,000 to get the liters per minute. So there was some rounding involved. It's very close to this answer here, 5,401. So that would be your answer. We can probably get closer to that answer if we do not engage in the rounding. So 0.136 times 0.136 times 0.785 to find that area of the circle again, and then not rounding that and multiplying by 6.2, and then multiplying that by 60 to give us the meters cubed per minute, and then multiplying that by 1,000 to get the liters per minute. And then yes, we get a closer answer. So if you round, generally the answers in the multiple choice quizzes will be fairly far apart. But if they are closer together, it might be crucial to keep all of the digits or as many of the digits as possible. So at 92 liters per second, how many minutes of contact time is provided in a reservoir 5 meters in diameter and 2.5 meters deep? So formula is that detention time is equal to the volume divided by the flow. Note that the units must be compatible. Well, the units always need to be compatible when we do this math. And the formula volume of a cylinder is 0.785 times the diameter squared, because that's the area of a circle again, times the height. So what we want to do is we want to figure out 92 liters per second. So that's going to be the flow in liters per second. How many meters of contact time is provided in a reservoir? 5 meters in diameter and 2.5 meters deep. So we're going to start by calculating the volume of the cylinder. So we know that the diameter is 5. And we know that the height is 2.5. So what we're going to do now is we're going to multiply this out. So 25 times 2.5 times 0.785 gives us 49.0625. And we also know that we need to use the formula for detention time, which is the volume divided by the flow. So we have the volume in meters cubed, and the flow is in liters per second. So remember that every 1,000 liters is equal to 1 meter cubed. So we want to divide this by 1,000. And that would be how many meters cubed per second it is. So if we take the volume and we divide it by 0.092, we should get the detention time in seconds. So we're going to do 49.0625 divided by 0.0992, and that would be it in seconds. So then we divide that by 60, and we get 8.888, which is very close to 8.9 minutes. Now for some words of general advice. So whenever you are writing a multiple choice test, it is a good idea to eliminate long answers to make answering the questions easier. So for example, up here, when we were dealing with the water flowing from a narrower pipe to a wider pipe, we knew that it was going to slow down. So you could automatically cross out some of these answers, like remain the same or increase approximately twice. We knew it wasn't going to go faster. So that's an example of how you can eliminate wrong answers. Do not spend too much time on any one question. If after you eliminate wrong answers, you still cannot hazard a guess, leave the question and come back to it later. While we do not use the units while doing the calculations in math, it is still very important. And with these circle questions, that's where we really ran into the problems with the units and making sure that they're the same. So it's very important to make sure that your result is in the same unit as that of the answer. Also, it is often easier to convert the units at the beginning of the question. Use the formula sheet, use your calculator if you're getting any exams, like certification exams. You will have a quiz that will be sent to you for you to complete as part of the CEU course. So you'll need to complete that course and that quiz and get it back in order to earn your CEUs. Thank you and have a great day. Bye.